Although northern analysis can reveal an increase in the level of mRNA for a specific gene, this increase could be due to mRNA stabilization, an increased rate of transcription, or both. You also might not know which of the genes are being actively transcribed. To determine if the rate of transcription is increased, or whether or not a specific gene is being transcribed, a nuclear run-on assay should be performed. Basically, nuclei are isolated from the control and treatment cells of interest at various times and incubated with p-UTP. The p32 labeled uridine will be incorporated into elongating RNA. At various times, the RNA is isolated and spotted onto a nylon or nitrocellulose membrane that has the cDNA of interest immobilized to it. In this case, it is a dot blot assay. The newly synthesized radioactively labeled RNA hybridized to that cDNA, the membrane is washed, and the unincorporated p-UTP and nonspecific binding are washed away. Then you can determine through autoradiography whether or not the RNA has bound. So in this case, in a nuclear run-on, we are interested in whether or not X, Y, or Z is being actively transcribed in the nucleus. So, as you can see, the polymerase is actually on gene Y, and that is what's being actively transcribed. And so by isolating nuclei that are actively transcribing gene Y, it would incorporate p32. In this case also, the slide indicates that the p32 is labeled to GTP. Most often you would do this with uridine, given that you would only then be incorporating into transcripts. After you've extracted, then you can blot it onto the dot blot, and in this case, the cDNA from gene Y would bind to the newly transcribed Y transcript, and then you would get signal.